Okay, I have a confession to make. Even the absolute brightest, most over-prepared students walk into their Cambridge OS 625 physics exam and they literally throw away guaranteed marks on the energy topic.
So, I want you to make a choice right now. Which energy transfer mistake ruins top grades? Is it A, missing your units? Is it B, giving vague explanations? Or maybe C, rounding too early? Seriously, make your choice right now. Lock it in.
Because if you guessed wrong, you're actively threatening your grade boundary. Falling into this specific trap costs a massive 3 method marks in a single calculation. And this is exactly why ordinary rote revision completely fails for physics. You can memorize every single energy store and transfer, but if you don't know the exact exam technique the mark scheme demands, well, you lose the points.
All right, Section 1, the big energy exam trap.
Look, examiners are actively hunting for these exact weaknesses. Over on the left here, notice the classic errors. We're talking missing units during your working out, rounding your numbers way too early in a multi-step calculation, and messing up graph axis scales. But on the right, those are your exam-safe corrections. You absolutely must include units in your substituted values, not just at the very end. You've got to keep the full significant figures in your calculator until the final step. These kind of weak practical habits and incorrect variables, they're exactly what separates an A star from a B.
Moving on to Section 2, 4 steps to full marks.
Okay, here is our core framework for literally any explain or evaluate question. Step 1, identify the physics concept. Step 2, extract the evidence or data from the source page or calculation. Step 3, apply your scientific reasoning. And Step 4, translate it into exact examiner wording. If you sequence your answers logically through these 4 steps, you're pretty much bulletproof.
So let's apply the first step of our framework to this mandatory syllabus definition, the principle of conservation of energy. It states that energy cannot be created or destroyed, only transferred from one store to another, right? This is your foundation. Correct terminology here is completely non-negotiable. If you use vague words like saying energy is used up instead of transferred, you instantly fail step 4 of our framework, the examiner wording, and boom, you drop the mark.
Now, in a moment, I'll show you the examiner clue that changes the energy calculation completely. But first, you really need the framework that makes that clue obvious. Because honestly, without it, you'll stare right at the clue and never even realize it's sitting right there.
Which brings us to Section 3, fixing a flawed answer.
Just notice the contrast here. On the left, we have a painfully flawed student answer. Look at that vague conclusion. It totally isn't supported by the data. And there's a glaring lack of units right in the middle of their working. Yikes. But look at the right side, the top band answer. They stated the correct equation, they clearly showed their substituted values, and they fulfilled the command word perfectly with that exam-safe wording. This is crucial. Number 3, writing out your full method secures 3 crucial method marks. Look at that calculation for potential energy. By explicitly writing E equals mgh and then actually showing your substituted values, like 2.5 kilograms times 9.8 meters times 10 meters, you lock those points in. Even if you completely panic and punch the wrong number into your calculator at the very last second, showing this exact method means you still walk away with those 3 marks. It's a total safety net.
All right, Section 4, your turn. This is an interactive challenge.
Okay, power equals work divided by time. The student wrote 500 divided by 12 equals 41.6. Their final answer is 41 watts. Now I want you to mentally write your own correction right now. Spot the error. I'm serious. This specific mistake trips up even the top students every single year. What exactly did they do wrong here?
Well, here is the examiner-style correction. First off, if 500 divided by 12 is 41.66 recurring, rounding it to 41 is mathematically incorrect. It should round up to 42 for 2 significant figures. So they lost marks for incorrect significant figure rounding, and they completely missed their units during the substitution phase. Always remember the Cambridge Examiner standard you see there. A strong answer absolutely must include correct terminology, the equation, substituted values with units, and complete fulfillment of the command word.
Section 5, the examiner's final verdict.
So the real takeaway here is this final answer practical checklist. Whenever you finish a calculation or an explanation, you've got to run through this mental list. Check your units. Verify your significant figures, which usually means matching the lowest number of sig figs given in the question data. Confirm your graph scale if you're pulling data from a chart.
State your uncertainty if it's a practical question. And finally, just ensure the reasonableness of your final answer. Like, if you calculate the power of a tiny toy motor to be 2 million watts, your final check should be screaming at you that something went very, very wrong.
But wait, what about the interactive poll from the beginning of this explainer? Which of those mistakes actually ruins the most top grades? And how on earth does it connect to the most heavily weighted formulas you'll face on the paper?
Well, I am actually leaving that totally unresolved right now, because the poll result and that final absolute deal breaker of a trap, they're fully revealed in our Physics 0625 Last 7 Days Revision Map Explainer. Seriously, you cannot afford to walk into that exam room without knowing how that heavily weighted question functions. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations, and click on the Revision Map Explainer on your screen right now to find out the answer. Go click it, and I'll see you over there.